Hello, welcome to today's lesson about similar triangles. So what's going on is you're going to be confronted with two triangles that are similar, and that's what this little squiggle in the middle means. And you're going to have to find some sort of unknown value, such as here, you have to find out what this x value is going to be. So right, if you have this triangle and it's similar to this one, there's some way to find out this x value based on that property. Well, there's actually two different methods for figuring that out. And if you're looking at your note paper here, this is the first one I'm going to go through, and it uses scale factor. If you go to the next slide, it's actually the same setup. It's got the same two questions, but you use a different method to get them. So we're going to use two different methods to get the same answers. And I want to show you both. Sometimes one is easier than the other. Sometimes you don't have necessarily everything for one, and so you can use the other. And so, yeah, there's a couple options for how to solve these problems. So we're going to focus first on using scale factor. And what that means is if you have two similar triangles, and by the way, similar triangles means they have the same angles. So these matching tick marks means they're the same angles. Maybe their angles are 30, 40, and something like that. 30, 40, and 110. Possible angles there. When you have two similar triangles, they're going to have the same angles, but the side lengths are going to be different. But if they are similar, that means they're dilations of each other. So going from one triangle to another, you can times by some scale factor or growth factor, whatever you want to call it. I think I call it, yeah, it's called scale factor. And so that factor of dilation is the scale factor, so it's timesing by. So let's say I have the original A value was 6, and then my D value was 20. And let's say I know my B and I want to find my E. Let's say my B value happens to be 10. And I want to find the E value. Well, you can find this scale factor, what do you times 6 by, to get 20. And then times 10 by that same scale factor, and it'll give you E. So if you're not quite sure what that is, you can divide by 6. Scale factor is 10 thirds. And you can times 10 by 10 thirds to get 100 thirds. And that's going to be the E value here. So that's what's going on. And you can do that to get any of the values on the other triangle. So let's jump down to this example. Again, we're going to find our scale factor. So it's like, what do you times one side by to get the other? And when you're trying to figure out your scale factor, you do have to go between corresponding parts of the triangles. And so I wouldn't be going from 7 to this here, because this does not match up with this side in the dilation. These are the pair that match up, and these are the pair that match up. And so you want to go just between sides that match from the dilation. And so we need to figure out what our scale factor is. And if you're not quite sure it is, okay, 7 times something is going to equal 56. You can divide by your 7 to find out what number that is, which is going to be 8. So I know this is my scale factor. I'm going to write that out, scale factor. So that means if I take 14 and times by my scale factor, I'm going to get 15x plus 7. So I'm going to do 14 times 8 to get 15x. That's a bad 5. 15x plus 7. And then I can finish solving this. 14 times 8, so use my calculator here, 112 equals 15x plus 7. And I can subtract 7, and then I'll divide by my 15 to get my x value. Let's give me x is, you get 7. All right, x is 7. So we found our unknown value for this x. Hooray! So there you go, that's using scale factor. What I'd like for you to do is come down to this next one and see if you can do it all by yourself. Just a little test of your abilities. I am going to kind of help you get started, though. These are overlapping triangles, so you got the small one and then the big triangle outside of it. these are the sides that are going to match up based on the dilation. The center of our dilation was here at S. So use the numbers you know to get your scale factor, and then set up an equation using the term with the x to find out your x. Set up an equation you can solve. So go ahead and pause and give it a shot. All right, let's see how it went. So going from 14 to 84, sorry, you're going to times by your scale factor, which I don't know it quite yet, so I'm going to divide by 14. And I got question mark is 6. So my, sorry about that. My scale factor is 6. So now that I know that, I can figure out, I can set up an equation using 9 and my 4x plus 2. It's going to times by my scale factor. So 9 times scale factor is the big one. So 9 times 6 is 4x plus 2. 9 times 6 is 54. And you can subtract 2. And you got 4x is 52. Divide by 4. And you're looking at x is 13, I believe. Let me check here. Yeah, 13. Ta-da! X is 13. So there you go. That's how you can use scale factor to find an unknown side in similar triangles, or unknown distances, variables, things like that. So that's method 1. Using a scale factor, you can figure out what missing sides are. Well, on the next page, again, it looks like it has the same setup, but this is actually a different method. So you can kind of think of this is scale factor. That's a bad factor. What this is here, this is equivalent ratios. Of corresponding parts. I'm going to just write that, corresponding parts. That's terrible penmanship, but you're going to see what it means in a second. So, if you have two similar triangles, the ratio of corresponding parts is going to be congruent across both. What that means is A and D here, these are corresponding parts, and if I were to put them in a fraction, like A divided by D, that would be a ratio of these corresponding parts. Well, a ratio using B and E. So if you did A over D, B over E would be a equivalent ratio of corresponding parts. You can also do C over F as your corresponding parts. But you can also do the flip version of these. Let's say that setup doesn't look nice, and you can flip any of these. So D over A would be the same thing as E over B, which would be the same thing as F over C. So however you set up one of your ratios, all of the other ratio of corresponding parts is going to be the same. You have to do it in the same method. So if you do small over big, you have to do small over big on all your other ratios. Or if you do big over small, you do big over small on your other ones. But there's also other setup you can do. And yeah, let's say you don't like that particular setup. You can actually do a ratio out of these values, and it's going to be the same as a ratio of corresponding parts on the other triangle. So you can have A over B and then D over E. And so you can have lots of different ratios you set up. Basically, you can set up any ratio of size you want if the other ratios you write out have the same corresponding parts. And so I'm going to kind of show you what that looks like on these examples down here. There's just a lot of them. A lot of possible equations you can set up. So what's going on is I'm going to write out these kind of ratios for you. And these are the exact same ones that were on the front, but I want to show you again, go through this particular process and realizing the answer is going to be the same. So let's say I pick a side, and I want to write a ratio with it. Well, I can have it correspond with 14 or 56 or even that one. You usually have to pick one. Let's have it correspond to 14 this time. Well, I can write out a ratio of 7 over 14. And that's going to be equivalent to another ratio using corresponding parts on my other triangle. So 7 was this bottom length, So the top of my other ratio needs to be the bottom length of my other triangle. And then 14 was this diagonal one. Man, my 5s has that long tail. Is my diagonal one here. So I go to my diagonal one here, and that has to be on bottom. So I'm going to put 15x plus 7. So this is an equation I can set up using the fact that ratios of corresponding sides of similar triangles are equivalent. Let's say I didn't like this particular step. I don't like having my x on bottom. You can just flip it. You can do 14 over 7 equals 15x plus 7 over 56. You could have set up other ratios. Let's say I didn't want this one. Say I wanted to do 7 and this one. So I could do, I can even do big over small this time. I could do 56 over 7. And I can do the big length over the small length and get 15x plus 7 over 14. And you could do the flip version of those as well. You could do 7 over 56 equals 14 over 15x plus 7. So there's just a lot of possible ratios. Any of these is fine. Any of them, if you solve it, you will get the correct answer. So really, you only need one. I just wanted to show you a bunch, realize you have a lot of different options. And I'm actually just going to pick one. Either of these is going to be easier, and that's just because the x value is on top. So let's just use this one. We'll have this be our equation that we actually solve here. 14 over 7 happens to be 2, so I should write that out. 15x plus 7 over 56. And now I need to get this out of the denominator. So I add times by 56. Times by 56. Let's see. 56 times 2 is 110. What was that? 56? Sorry, 112. Blah. 112 is going to equal 15x plus 7. And now I can subtract 7 and divide by 15 to get my x value. Which I did that last time. I can't remember what it is though. 7. It's 7. So x is 7. And again, you could have solved any of these and you would have gotten the same answer. Like here, I could have times both sides by 14, subtracted 7 divided by 15, and you get the same answer. So what I'd like for you to do, jump down to this one, and I want you to set up your own equivalent ratio equations. You only need one, but you should try out a few of them, see if you can do it by yourself. Go ahead and pause the video and see if you can write out a few. All right, so I'm going to write down a few options for you. Let's say I want to have these be my corresponding parts. I can do 14 over 84, and that's going to be 9 over 4x plus 2. You can also have the flip version of that, so big over small of these same ones, like this. You could have related these in a different way. Let's say I want to use these two sides of my small triangle, and that will correspond to these two sides of my big one. I can have 14 over 9 equaling 84 over 4x plus 2. Or you can have the flip version of either of these, 9 over 14 being 4x plus 2 over 84. Let's see. You could have done. Well, there's a few. Yeah, you got some options to work with. Well, you only need one of these, and if you got one of these, awesome. If you had a different one that still has corresponding parts matching up, that'd be great. I'm just gonna pick one. I'm gonna pick this one as the one I'm going to solve, so we can get a final answer here. So what I'm gonna do here is I'm going to times both sides by 9. I want to get this x by itself, so I'm going to bring that 9 times by 9. I'm going to bring it down here. 84 times 9 divided by 14. It's going to give me 54. Equals 4x plus 2. Calculators are really good at this stuff, so you should, invest in using calculator. Subtract some 2. You get 52 equals 4x. And divide by your 4. And we get that x is 13 once again. So, ta-da! Hopefully you're kind of seeing that. You can see how this is solving your similar triangles using a different method. I kind of like this one. It gives you one equation to solve instead of getting scale factor and then using that to get other measurements. But there's lots of options on how you solve these. So there you go. Hopefully that gives you an idea of how to solve similar triangles. It really takes practice. Try it out, go to your assignment, and see if you can do some solving. Good luck.